Today we'll continue our study of least squares regression lines. Yesterday we learned just how to interpret the slope and the y-intercept of a least squares regression line that was already given to us. Today we'll use technology to calculate least squares regression lines. It'll also calculate the correlation, and we'll learn how to use our calculator to draw a residual plot and then to interpret that. So just a little background on a least squares regression line. We'll talk about that so much that we'll call it the LSRL, for least squares regression line. And what happens with a least squares regression line is it makes the sum of the squares of the residuals as small as possible. And just so you will understand what I mean here, there are lots of different methods for calculating a least squares regression line, but the one that we'll use is this one that makes this sum of squares of the residuals as small as possible. So as you can see right here, what's happened is here's a data point, here's the vertical distance to the line, this is a residual, and literally what's happening is if I square this, I'm going to get, some kind of area right here. So this, the graph on the right indicates to you that what's happening is when the calculator calculates the equation of this line, it's literally trying to make the sum of these little squares as small as possible every single time. You don't really have to know how, obviously you can't do that yourself, but it's just nice to kind of understand how the calculator is coming up with that line. To find it on your calculator, on the TI Nspire, when you're in your spreadsheet, you'll do the same thing, excuse me, that we've done many times before, where we press menu and we've gone to statistics and we've chosen stat calculations. And we've chosen one variable, stats, right there before. This time you'll choose number 4, linreg, and use the a plus bx one. There's a y equals mx plus b too, but we typically use y equals a plus bx in statistics. And then the next thing you need to understand is what we mean by a residual plot. So one idea that we need to think about here is knowing if our line is a good model for the data. Sometimes what can happen is you can get a really high correlation coefficient, meaning strongly linear, but then when you look at how the line fits the data, you realize that it was actually maybe slightly curved or something, and you wouldn't necessarily know that just from your R. So a residual plot will help us determine if a line is actually the best fit for our model. So here you can see that what I have is the scatter plot. I think this is still for the Ford F-150 trucks and the miles driven and the price. So here's the best fit line with through the data points, and this is a residual plot, and all it's doing is plotting separately all these little vertical distances from the line, and that just gives me a good idea of how the fit is of this line. So let's just talk for a few minutes about what you should look for when you look at a residual plot. So the first thing is the residual plot should show no obvious pattern. So what do I mean by that? Well, just like we saw in the previous example, the residual should be, pretty much randomly scattered above and below the x-axis. Something like that. And the residual should be small relative to the data. So in other words, if you're talking about populations that are in the millions, then it might be okay to have residuals that are in the 100,000s or something like that. So just keep in mind that they should be small relative to whatever your data set is. And then if you have an obvious pattern in the residuals, this means that a line is not the best model for the data. And here's what that could look like. The residual plot actually looks curved, like so. This means that the data, even though we may not have been able to see it when we first looked at this, just the scatter plot of the data, but it means that the data was actually curved, and some kind of curved model like an exponential or a quadratic or something like that would be a better model for the data. So it doesn't tell us what that better model is, it just tells us that the line is not the best one. You have a couple of quiz problems on Blackboard, so you should do those now. And tomorrow I'll help you with your calculator and learning how to actually calculate the LSRL on your calculator and then view the residual plot.